This is locked. I won't take more than 30 minutes. I won't take more than 30 minutes. It's just a...
Let me keep my belongings.
Okay. Good morning, everyone. I want to believe I'm audible enough. Yeah, I want to believe I'm audible enough. Can you hear me? Okay, this very morning we're going to be continue from where we stopped. We have just about 20 slides on chemistry of carbohydrates, and we basically touched those ones that that are very, very important, and we're going to continue from where we stopped last time. Okay, So from the previous slide, we were at disaccharide. We were at disaccharides, okay? So we want to go to the lecture properly to finish the remaining slides, okay? So we are at disaccharides, and we have said that basically the disaccharides are the maltose and maltose, lactose, and sucrose. These are the three major disaccharides that we are conversant with, and importantly is that these major disaccharides we have is that maltose and lactose are reducing sugar. They are reducing sugar based on the fact that they have a free functional group that makes them to react with a reducing agents. Okay, they have free functional group that makes them to react with a reducing agent, and as a result of that, they become a reducing disaccharide sugar. Okay, and importantly is that this disaccharide we're talking about is a combination of one monosaccharide with another monosaccharide to form disaccharides. One monosaccharide with another monosaccharide coming together to form disaccharides. Basically, that is the way they are formed. Our disaccharide is a combination of one monosaccharide with another monosaccharide, as we could see, for instance, in sucrose, where glucose combined with fructose. We could also see in lactose, where galactose combines with glucose. Also, we could find in maltose, where glucose combines with glucose, all right? And importantly is that the arrangement of this formation, the arrangement of this formation, the arrangement of this formation is in such a way that they have a linkage that tends to link them together. They have a linkage that links them together, and this kind of linkage are what actually form the bridge between these monosaccharides. Okay, so what form the linkage between the monosaccharides. Okay, and for maltose, we have said maltose has a combination of two glucose coming together. Okay, combination of two glucose coming together. Okay. Okay, this is one glucose, it's another glucose. So this kind of linkage is what is actually, this is a maltose sugar, a disaccharide, a decent disaccharide. The linkage that is existing between the one molecule of glucose with another molecule of glucose is what we refer to as glycosidic bond. This is a bond linking these two glucose, molecules of glucose together. And because of the existence of this glycosidic linkage, this is for maltose, this is referred to alpha 1,4 glycosidic linkage. And how did we arrive at this alpha 1,4? This is first carbon for this, and this is the fourth carbon for this glucose. So as a result of that, the linkage is being formed between alpha 1 because of the position of the hydrogen and the hydroxy group. So alpha 1 at position 4 of the other mole of glucose, making alpha 4 linkage. Okay, that's basically how each of these glycosidic bonds do exist. And as well, we will also see a similar combination that do exist between lactose. Lactose is formed by the combination of two monosaccharides. Okay, two monosaccharides, that is glucose and galactose. Okay, glucose and galactose. Okay, forms okay. Okay. This is lactose, another disaccharide, which is also a reducing sugar. It's a reducing disaccharide sugar. And this combination of linkage is formed between a beta 1,4 glycosidic bond, okay, between beta 1,4 glycosidic bond. And lactose is formed by combination of glucose with galactose. Okay, so this is how this linkage. The same thing applies to sucrose, which is a combination of glucose and fructose coming together. All right. So we want to move quickly to oligosaccharides. And we have said that the oligosaccharides these are carbohydrate sugar that are less than 10, between 3 to 10 precisely, the oligosaccharides, the combination of monosaccharides that ranges between 3 to 10. 3 to 10 oligosaccharides coming together to form 3 to 10 monosaccharides coming together to form our oligosaccharides. Okay, and a good example of oligosaccharides is raffinose sugar. Raffinose sugar. The typical example of an oligosaccharides that ranges between 3 to 10. Okay? Apart from raffinose, we also have stachylose, which is containing 2 molecules of galactose with glucose and fructose. Stachylose contain 2 molecules of galactose plus glucose plus fructose. Okay, this is what makes stachylose, and whereas the raffinose is a combination of galactose plus glucose plus plus fructose. So all of these are classified as oligosaccharides. We want to quickly move to the polysaccharides. These are the polymers. Polysaccharides. Polysaccharide. Poly means many, and saccharides means sugar. So this is a combination of many sugars coming together. They contain more than 10 sugar subunits. They have high molecular weight. Importantly, is that they are sparingly soluble in water. They are also referred to as glycans. We can call them as glycans as well. Glycans. They can be referred to as glycan. Another important characteristics of these polysaccharides is that they can be linear in structure or branched. They can be linear or branched in structure. Structure-wise, you could have them linear. We could also have them branched. Okay, it could be linear. It could be branched in structure. Okay, so that is what makes the polysaccharides. And a typical example of these polysaccharides is starch and glycogen. Our starch and our glycogen. We also have other forms of polysaccharides, such as inulin, agar, okay, pectin, okay. So all of these are class of polysaccharides that coexist in living organisms. And broadly, the polysaccharides, can be divided into homopolysaccharides, and heteropolysaccharides. Okay? And what do we mean by this? That this talks about homogeneous repeating units of monosaccharides come together to form a polysaccharide. In this case, which is the heterosaccharides, they have different subunits of monosaccharide coming together to form hetero. Hetero means different. Okay? And under the homopolysaccharides, we have the starch. Your starch, you have your glycogen. Glycogen. We also have dextrin. We have dextrin. For heteropolysaccharide, we have agar, we have pectin, we also have inulin. Okay? These are groups of classification for different polysaccharides we can see in living organisms. We also have cellulose. We have cellulose, we have amylose, we have amylopectin, we have glycogen, okay? And for each of these different class of polysaccharides, they have different linkage according to the slide lecture I gave to you guys, okay? For instance, in cellulose, the bond that exists there is alpha 1. In cellulose is alpha 1 glycosidic linkage. Okay? And also for amylose, amylose is also alpha 1 amylose. Alpha 1 linkage. Okay? And for amylopectin, it coagulates alpha 1 4 and alpha 1 6 for amylopectin. Amylopectin. Why glycogen is a combination of 1 4, alpha 1 4 and alpha 1 6, glycogen. Okay? These are the kind of linkage that you will actually get from this polysaccharides. So we want to pick and go into these polysaccharides. And the first one we're going to talk about is the common starch that we are very familiar with. Okay, we want to talk about the starch. The starch we take has died. So we said the starch has amylopectin that is branched with 1,6 linkage and 1,4, understand, which could be branching as well. 1,4 amylopectin is part of what makes the repeating units of this starch. Okay, and starch usually can be hydrolyzed to form dextrin. Dextrin. So glycogen, this is another form of polysaccharide and is the energy storage form in animal, and it has its higher concentration in the liver, okay? In the liver, so as well in the muscle, and also in the brain. Okay? There are places in the body in which you will have a deposit of glycogen. So excess glucose taken by the body is stored in the form of glycogen for energy usage as a storage form. Okay, we want to move to cellulose. Cellulose is the major constant of plants' cell wall, and it is linked by beta 1,4 glycosidic linkage. And importantly is that humans don't have a typical enzyme for cellulase that will actually digest cellulose in our body. So another important Another important polysaccharides we will mention is inulin. It's a polymer of D-fructose, which is linked by beta 1,2. Inulin is linked by beta 1,2 glycosidic linkage. Okay, beta 1,2 glycosidic linkage, and of chemical or biomedical importance that we use inulin in research to assess the function of the kidney by measuring GFR, glomerular filtration rate. Filtration rate, also known abbreviated as GFR. Okay, this is a clinical piece of clinical importance among those tools we use to assess the function of the kidney. Its clearance gives a better performance of how the kidney clears toxic or its byproducts, as it were. So we want to move to the mucopolysaccharides. The mucopolysaccharides. These are the combination of carbohydrates with other biomolecules to form the ground substance of tissue material in our body system. Under these mucopolysaccharides, they are also referred to as glycoaminoglycans. They are also called glycoaminoglycans. An example of them is chondroitin, sulfate, heparin, dimethan, and keratin sulfates. And each of these mucopolysaccharides are found at different tissue of the body. Found at different tissue of the body with different composition. Found at different tissue of the body with different composition. For instance, we have hyaluronic acid, and this is found in various of the tissue connective tissue of the body, and also in the vitreous human. And in those areas where it is located, it serves as lubricant, shock absorber, and promotes wound healing. We also have heparin, which acts as anticoagulant. Dimethyl sulfate maintain the shapes of the tissue. You have keratin sulfate, which keeps the cornea, and is found mainly in the cartilage and the cornea of the eye. So this leads us to the end of the remaining lecture on the chemistry of carbohydrates. Here is your clinical correlates. Your clinical correlates is to talk on lactose intolerance. Lactose intolerance. Lactose intolerance. That is your clinical correlates. And lactose intolerance is one of the clinical conditions we do find in affected population due to the fact that the affected patient cannot metabolize lactose because of deficiency of lactic enzyme. And such affected patient or people present with diarrhea, present with bloating, abnormal digestion of the lactose, especially when they've taken dairy food, milk from dairy. So as a result of that, this gives unwanted abdominal discomfort with indigestion, with bloating, diarrhea, and nausea, as it were. So prepare a lecture on lactose intolerance and go to the extent to comprehend what is responsible for lactose intolerance and why are people having it, especially those who are suffering from it, and what is the cause, the causity. All right, so thank you very much for your time. This lecture is going to take just about 30 minutes of our time, and we have come to the end of the chemistry of carbohydrates and structure, because that is what we actually did finish, and we just want to go through it for our own, comprehension, as it were. So thank you for your time. I really appreciate you giving the time out. Have a nice weekend. Bye for now.